Hello and welcome to 4.3 part 2. We're going to be looking at some new trig ratios today, and we're going to be looking at how to draw a point in standard position and calculate the exact values of all of the trig ratios. So just a reminder as you're going through these videos that you can pause at any time, you can speed up or slow down the video, you can skip backwards or forwards if we're either going too slow for you or too fast for you. So just a reminder about right-angled triangles. You have a right triangle, ABC, with an angle theta in the corner. Side AB is your hypotenuse. Side BC would be opposite to theta. It is the angle, the side that is across from your angle. And AC would be your adjacent. So adjacent means beside. Hypotenuse is always the longest side of your right angled triangle across from the right angle. And opposite is always the side across from your angle theta that you are looking at. So a reminder that you have sine, cosine, and tangent as your primary trig ratios. You should be comfortable with these from Math 10 and 11. And you might use SOHCAHTOA to remember which one is which. So sine is the ratio of opposite over hypotenuse. Cosine is the ratio of adjacent over hypotenuse. Tangent is the ratio of opposite over adjacent. Now we're going to be learning today about three new trig ratios, and these are your secondary trig ratios, and they are simply the reciprocals of our three primary trig ratios. So cosecant is written CSC theta, and this is 1 over sine theta. It is the reciprocal of sine. And if you take the reciprocal of your sine ratio, you would get hypotenuse over opposite. Secant, SEC, is the reciprocal of cosine, 1 over cosine theta. If we take the reciprocal of the cosine ratio, this would be hypotenuse over adjacent. And cotangent is the reciprocal of tangent. And this would be adjacent over opposite. So notice how this is the ratios that are flipping. It's not the angle that is flipping. It is the ratios of the sides. And you have no button on your calculator that does this. You would literally have to find your sine, cosine, or tangent ratios and then do the reciprocal of that. So if that's a fraction, you can simply flip that fraction. If it's a decimal, you can do 1 over that decimal. So let's try a question. We've got the point 4, -3, which we know would go somewhere over in quadrant 4. And it's on the terminal arm of an angle theta. So we're going to draw ourselves a terminal arm, and we know that theta would be measured something like this. And this is the point 4, -3. We are being asked to find all 6 trig ratios in exact values. So we probably should draw ourselves in a triangle. As soon as it says trig ratios, you know triangles are involved. Now, if we know that this is 0.4, -3, we know the distance on the x-axis is 4, and the vertical distance is our y value, which is -3. Now, the only problem here is that we don't have a hypotenuse, and we will need a hypotenuse for our trig ratios because that would be our hypotenuse in our ratios as well. Okay. Now, we also know that when we're looking at these triangles, we're usually looking at the reference angle here as our theta. So if I want to find our hypotenuse, remember we usually call that r because we're thinking of this as being a terminal arm swinging around a circle, and that's the radius of that arm. So we can find r because we know that a squared plus b squared equals c squared, or 4 squared plus -3 squared is going to equal r squared. We're going to get 16 plus 9, or 25. Which means that r is the square root of 25, which is 5. We know it's not -5 because the radius of a circle must be positive. Now that we have that, we can find our sine, cosine, and tangent. Sine is opposite over hypotenuse. Our opposite is -3. Our hypotenuse is 5. Cosine is adjacent over hypotenuse. Our adjacent is 4. Our hypotenuse is 5. And tangent is opposite over adjacent. That would be -3 over 4. Now, the other three here are simply the reciprocals of these. Cosecant is the reciprocal of sine. That would make this 5 over -3. Secant is the reciprocal of cosine. This would be 5 over 4. And cotangent is the reciprocal of tangent. That would be 4 over -3. Now, if we want to calculate theta, we can use any of these trig ratios to do so. I like tangent. I don't know why, but it's my favorite, so I'm going to use that one. And I know that tan theta is -3 over 4. Now, if I'm trying to find the theta value, a reminder that you need to use your second or shift function on your calculator so that we can do the inverse of tangent to find theta. So we're going to do inverse of tangent of -3 over 4. Okay. Now, when we do this in our calculator, we need to decide if our answer is going to be in radians or in degrees. So right now, it doesn't tell us. I will probably use degrees simply because that's what we're comfortable with, and it didn't tell me that I needed to use radians. Okay, so if I do negative shift tan of -3 over 4, I get -36.8698, etc. So 99, or theta is -37 degrees. Now we might be going, well, why is this negative? And it's negative because if I'm looking at this as an angle, I either went positive in my clockwise direction like this, or I traveled negative direction this way down to my terminal arm. Okay. So if 37 degrees is essentially my reference angle in there, okay, so I could write this instead as theta equals whatever 360 minus 37 is, which gives me 323 degrees. So we can see that we've got two possible answers here. The question did not tell us what type of angle we needed. It didn't give us a domain for this angle. So -37 would be an acceptable answer, or 323 would be an acceptable answer, depending on which direction we see this terminal arm traveling. So a reminder from Math 11 that each quadrant gives us different signs. In quadrant 1, all of our trig ratios are positive. In quadrant 2, just our sine trig ratio is positive. Quadrant 3 was just tangent, and quadrant 4 was just cosine. Now, these will also inform our reciprocal functions. So all includes reciprocal functions. Sine being positive, this means cosecant also would be positive. Tangent being positive means cotangent is also positive. And cosine being positive means secant would also be positive. So if a trig ratio is positive, its reciprocal must also be positive in the same quadrant. So you may have learned an acronym to remember this in grade 11. So there's two different ones that are common. The first one is if we start in Q1 and proceed counterclockwise, so around this direction, our acronym is all students take calculus. So the A is quadrant 1, meaning all of our ratios. The S is for sine in quadrant 2. The T is for tangent in quadrant 3. And the C is for cosine in quadrant 4. Our other option is if we start in Q4 and proceed counterclockwise. You can remember the word cast. So again, the C is in quadrant 1 for cosine, quadrant 4, sorry, for cosine, the A in quadrant 1 for all, S in quadrant 2, and T in quadrant 3. So given the following conditions, which quadrant would theta be in? If cosine is positive, we're either quadrant 1 or quadrant 4. But then we also know that tangent is negative here. This means tangent is negative. So it can't be quadrant 1 because tangent is positive in quadrant 1, which means we must be in quadrant 4. If you'd like to pause here to try the next one on your own, you can. Otherwise, you can proceed with us. The next one, sine is negative. This means we must be in either quadrant 3 or quadrant 4. And then we have that cotangent is positive. So if cotangent is positive, that means tan theta is also positive, which would mean we are in quadrant 3 because tangent is positive in quadrant 3, but not in quadrant 4. All right, so let's try a couple questions here. So we want to find secant in exact value. This means we should have roots or fractions, no decimals. If theta is in quadrant 2, so quadrant 2, somewhere over here. Okay. And when we draw in our triangle, remember we're usually talking about a reference angle in here. Okay. And we know that cotangent is negative 5 over 12. If cotangent is negative 5 over 12, then tangent is negative 12 over 5. So this means my opposite is 12, my adjacent is 5, and the negative must go with the 5 because this is the negative x-axis here. Okay. Now we know that secant is the same as 1 over cosine. Sorry, you might just hear a printer in the background here. So if secant is 1 over cosine, we can find our cosine for this triangle, and then that will help us find our secant. Now for cosine, we know that cosine is adjacent over hypotenuse. So we need to find the hypotenuse. So 12 squared plus negative 5 squared would give us r squared. So this gives us 144 plus 25 is r squared, or 169 is r squared. Square root of 169 will give us r, which means r is 13. So our adjacent is negative 5. Our hypotenuse is 13. This is our cosine theta. We want secant theta, which is the reciprocal of cosine theta. Therefore, secant theta is negative 13 over 5. Okay. Again, if you are like, you know what, this isn't too bad, maybe pause here and try the next one, and you can skip forward to the answer. If you would like to walk through this with us, you can continue here. The next one is asking us if theta is on terminal arm, find the measure of angle theta if sine theta is equal to negative 1 over 5. So we know that sine theta is negative in quadrant 3 and quadrant 4. So we have two terminal arms we need to draw here. One will go here, and one will go here. It does not matter where exactly in those quadrants you draw them, but they need to be in quadrant 3 and 4. Now, we know that one of our thetas would measure here, and the other theta would measure all the way around here. So we have two possible angles as our answer. One that would land in quadrant 3, one that would land in quadrant 4. Now we also know that sine is opposite over hypotenuse. We know the hypotenuse cannot be negative, so our opposite side must be -1. This is what our triangles will look like. Now we're trying to find theta, which means we probably need a reference angle to help us with that. So if I have sine theta is equal to -1 over √5, if I do the inverse of sine, so let's put our theta on this side, of -1 over √5, we're going to get a theta value. Now, when we do this, we are going to get a negative angle. So that's going to represent our quadrant 4 angle. If when we plug this into our calculator, we do the inverse sine of +1 over √5, we would get our reference angle. Okay. When we plug this into our calculator, again, it doesn't say radians or degrees, so I'm going to use degrees here because it's what we're comfortable with. We're going to get -27 degrees. So this would be in quadrant 4. And this means that our reference angle is 27 degrees because our -27 would be going this direction. Okay. So if our reference angle is 27 degrees, that means this angle here is also 27 degrees. And that means that we can figure out where that quadrant 3 terminal arm lands. Okay. So our Q3 angle is going to be 180 plus 27 degrees, which gives us 207 degrees. Our quadrant 4 angle, we can either write as -27 degrees, or we can do 360 minus our reference angle, which would give us 333 degrees. So we should have two answers there because they did not give us enough information to narrow down to a single quadrant. Okay. All right, so just a couple more examples here. So determine each of the trig ratios, draw a diagram to support your answer. The diagram is going to support whether our ratio is positive or negative based on where that angle falls. Okay. If you see something like nearest hundredth, this means we're going to use a calculator. These are not special angles. Okay. We use exact value. This means this is an exact trig ratio from one of our special triangles that we went over in the previous lesson. Those special triangles you must know. Okay. So this means from special triangles, which means you should not be using a calculator. You should have a fraction answer. And if you have radicals, you leave those radicals there. Okay. So if I want to do cosine of 260, okay, this means we're going to use our calculator and we need to be in degrees mode. Okay. And we're literally just going to type in cosine 260 equals. Your calculator, you might need to type the number first and then hit the cosine button, but that's something you need to know about your own calculator. And we should get -0.17. And if I draw this, 260 degrees falls here. And in quadrant 3, cosine is negative. So this makes sense that our answer was negative. Okay. This here, same thing, we need to use the calculator. And because of our degrees here, we need to be in degrees mode. Okay. Cosecant is the same thing as 1 over sine of our angle. Okay. So we need to figure out what is sine of -70 degrees and then do 1 over that. So in your calculator, you will type sine of -70 degrees, figure out what that is, and then do 1 divided by that answer. We should get -1.06. And if I think about this, -70 degrees is down here, traveling in the opposite direction that we're used to. and this is in Q4. Sine should be negative in Q4, therefore cosecant should be negative in Q4. Next one, sine of 135 is an exact value from special triangles. So 135 degrees should be in quadrant 2. As soon as we're doing special triangles, we need to draw in our triangle, write in our reference angle, which in this case would be 45, and label our special triangle. 45 degrees is a 1, 1 root 2 triangle. And because our x is in the negative x-axis, this should be negative 1 here. Now I know sine should be opposite over hypotenuse. So sine of 135 is going to be 1 over root 2. You might rationalize this and write this as root 2 over 2 instead. Last one, this one does not tell me if I am going to be using exact values or to the nearest hundred, but I can tell by looking at it. I've got pi over 6's. Pi over 6 is a special angle, so I should know to use special triangles. Okay. I also know that cotangent of 5 pi over 6 should be equal to 1 over tangent of 5 pi over 6. Okay. So if I draw this will help me with my triangles. 5 pi over 6 goes in quadrant 2. This would be my theta, my 5 pi over 6. Question is, what is my reference angle? I'm labeling a triangle. My reference angle here is pi over 6. So I need to label this triangle. This would be a 1, 2, root 3 triangle. 1, 2, root 3. And the root 3 would be negative because that's a negative x-axis. Tangent of 5 pi over 6 is opposite over adjacent. This would be 1 over negative root 3, which means that cotangent of 5 pi over 6 is the reciprocal of this, which would be negative root 3 over 1. I don't need to write the over 1. Last question. Determine the measures of all angles that satisfy the following. Use diagrams to support your explanations. So here I have cosine is equal to negative 0.366. This means we're going to need to be in quadrant 2 and quadrant 3. Okay. So we're going to have two possible angles here. One of them will be in quadrant 2 here, and one of them will be in quadrant 3 here. So I need my reference angle in order to do that. If cosine is equal to negative 0.366, the inverse of cosine will give me theta. Now again, when we do this, we're going to get a funny angle here, okay? Because we've got negative 0.366. When we do this, we're going to end up with a negative answer, okay? Or we're going to end up with an angle that maybe doesn't make as much sense as we've seen before. So if I try this in my calculator, I get 111.46, so I'll say 111 degrees. The question is, which angle is this? Well, this would have to be theta 1. So now the question is, how are we going to figure out what our other angle is? Well, if theta 1 is 111, we can use that to find our reference angle in here. Okay, so our reference angle would have to be 180 minus 111, which is 69 degrees. And this will help us find our second angle, which is 180 plus our reference angle. Okay, so 180 plus our 69, which would give us 249 degrees. So I have two possible angles here. And this told me that I wanted to be in degrees. So again, if you'd like, you can pause here and try the next one on your own. Otherwise, you can continue with us. So for the next one, our domain tells us we're going to be using radians. Okay. I also know that if secant theta is 2 over root 3, cosine theta is the reciprocal, which would be root 3 over 2. Now, hopefully those look familiar. Root 3 over 2 is positive. That means our cosine is in quadrant 1 or quadrant 4. And our opposite is root 3. Our hypotenuse is a 2. Our adjacent is root 3, not our opposite. We're using cosine, not sine. Apologize. Not letting me erase. Okay, so our root 3 should be here. And our 2. We hopefully notice that these are sides from a special triangle. It's our 1, 2, root 3 triangle. This means the other side should be a 1. And for the bottom triangle, that's actually a -1 because our y's are negative. Now I know that I have a reference angle in these corners here that I should know from my special triangle. Our reference angle would be 30 degrees or pi over 6. We want to use the pi over 6 because of the domain given to us in the question. So in Q1, our theta is just equal to pi over 6. And in Q4, our theta is going to be 2 pi minus pi over 6, which is 11 pi over 6. Okay. And that is it for this section. Again, remember, you can always scroll back and look at any of the examples again if you need to.